We need your help solving this mystery. To figure this out, we must examine the DNA from a foreign blood sample found at the crime scene. The lab uses polymerase chain reaction to amplify the DNA from the blood sample. PCR is quantitative because it increases the yield of DNA, and it's also qualitative because it allows for the close analysis of DNA fragments. So who discovered PCR? Carey B. Mullis discovered PCR in 1985 and won the Nobel Prize in Chemistry in 1993. His groundbreaking discovery occurred in the lab where he analyzed Thermus aquaticus bacteria to derive thermostable DNA polymerase. So how does it work? PCR requires the addition of a DNA template, DNTPs, DNA primer, Taq DNA polymerase, and a buffer solution. The process begins with denaturation, where the double-stranded DNA is separated. Next is annealing, where the primers are attached to each single-stranded DNA. And lastly is extension, where nucleotide bases pair with DNA for replication. So why is PCR useful? It is a rapid technique that produces DNA copies within hours. It is simple to understand and utilize in the lab, and it is an inexpensive amplification method. Amazingly, PCR can also be used for parental testing to determine biological parents, genetic testing to analyze genetic diseases, can assist in early cancer detection, gene expression to mass-produce proteins, and DNA sequencing. So let's find the culprit. Amplified DNA matches Emma. Remember, PCR is revolutionary and can produce millions of DNA copies.